So we are Team ChromoCam.
And I'm Alexander Sverdlovs.
Sam Whitney.
Chris Zhang.
And I'm Jake Herman. And so our problem emerged because Chris, Sam, and Alex's house did not have a peephole, so they had no way of determining who was at the door without having to first open it. So we determined that our problem was that, or the needs to fix our problem was that we needed to be able to determine when someone was at the door, and then we also need to be able to see who is at the door without first opening it. And our objective became to create a solution that could fix these needs while maintaining an affordable cost akin to the budget of a typical college student. And so the ChromoCam project was conceived. It's a low-cost, off-the-shelf, and open-source solution that uses motion detection to determine when there's someone at the door. And when the detection is activated, it sends the image to an Android application for the user to view. And it uses a few different hardware pieces. We have the Raspberry Pi, which is just an affordable computer, and it allows the processing of visual data and storage, the storage of data and the transmission of data. We have a USB Logitech camera that it's also just a cheap webcam that can hook up to the Raspberry Pi via USB, and it can have instant compatibility with the Linux Raspbian operating system. We have a magnetic door sensor for that's for when people are leaving the house. We don't want the motion detection to activate and capture a picture of them leaving because we already know when they were there and who it was. So that's just to shut off the motion detection for a small amount of time. We have a wireless router, and that just allows the propagation of visitor notifications and the subsequent notifications in the same household. There's a USB Wi-Fi adapter that hooks up to the Raspberry Pi, and that's just so it can connect to the local wireless network. And finally, there's just a typical Android phone, and that's just something that most of us, we all carry around. We're more familiar with developing on that operating system, and it has the equal capability to iPhones at a fraction of the development bureaucracy. So there's a few different requirements and constraints for the ChromoCam. These are a few of them. When motion is detected, a notification is to be sent to the user's smartphone, and the user is to be able to turn off these notifications if they don't want to receive them, and the notification has to be sent at a reasonable time frame. Dead zones need to be set, so that's to alleviate the problem of the camera picking up small and unrelevant or irrelevant motions, such as animals moving across the camera or a tree in the background, the branches swaying. Just set that as a dead zone, and that way it won't pick up irrelevant motions. You need to be able to access a live feed at any time and also request a still snapshot at any point in time. The user can modify the configuration files for the motion software package. The system needs to be able to be temporarily disabled via the magnetic door sensor. Mobile devices need to be individually distinguishable. The captured media needs to be able to be archived, either permanently on a database, or you could do it locally. And the user can determine whether or not they want to archive these images. And finally, the transmission of files needs to be secure. And a few of the constraints are that the hardware, it needs to be affordable. I mean, we're all college students on a budget. The network needs to have reasonable upstream. There needs to be a accessible power supply nearby. The media format has to be compatible to the current Android platforms. And finally, the camera needs to be able to withstand inclement weather conditions. That's going to be outside of the door. This is just reiterating the hardware.
It's pretty much just how all the different modules are connected. That's what Jacob.
Yeah, this is what I just went over, the hardware.
Yeah.
So one of the concerns is security, like Jake just mentioned. So in order to alleviate that, we want to have secure data transmission from end to end. That's between the Raspberry Pi and the end devices, the mobile phones. So we'll be using HTTPS to encrypt the data, or to have data encryption and have it be transmitted without people to be able to sniff it and see what exactly is being transmitted. And the primary areas of concern there are on the local wireless network. So if we have nosy neighbors, we don't want them to be able to see our traffic. And then the mobile data network, between cell towers and people's phones, the potential for people to be able to intercept that traffic. We want that to be secure as well. Additionally, we're going to have an authentication process. So we only want trusted phones to be able to access our system. And so we will have a registration process where there is an access password that you have to enter when you first use the app. And that password is either set by the system administrator, or there's an option that we will have for the system to randomly generate those passwords, and they can expire after a certain period of time if you wish to have it be more secure. The downside to that is that the administrator still is the one that has access to that password, so it's a little bit more of a pain in the neck if the administrator is not at the system right there to give somebody the password. And so once a device is registered, it will have a unique identifier so that the system recognizes it. So when it's communicating to the API, it has successful interactions with the API, because if it's not identified and not authenticated, then the API will just reject any requests.
All right, so this is an overview of the motion detection software that we will be using. It's called Motion, originally, and it's basically open source software under the new public license that will basically sense the changes in pixels between frames, and if the change is great enough, then it considers it as motion. And so we had some other alternatives that could be used. YawCam was an alternative, but unfortunately it only works with Windows, and that doesn't work with the Raspberry Pi due to it being low power and running on Linux. And then we also thought about using Connect, but we don't want to put a Connect outside our door because it would potentially get stolen and the costs are fairly high. And so the other reason we chose Motion is due to its fairly robust feature set. So some of the important functions that we'll be using is obviously the real-time motion detection from a video feed. It allows a custom resolution and frame rate, and this is important because as the Raspberry Pi is a low-power system, it won't be able to handle 1080p 60 frames per second, so being able to change that for the feed is pretty convenient. And it allows customization of certain parameters. So they're in the configuration files. You can set a threshold for the number of pixels that are required to be considered as a motion event. Through the configuration files, you can set the dead zones to ignore motion in certain areas of the picture. And then additionally, there's other useful functions such as SQL database logging, light switch functions, so that if lights are turned on or off, the changing light doesn't trigger motion. And then it also has an HTTP API for interacting with the configuration files, and that's how we plan to have the Android application be able to change the configuration files. So,
okay, so Motion will be directly interacting with the database and our web server, which will be hosting our API. So its interactions with the database will be when motion is detected and a picture or video is captured, that metadata will be stored into the database for further reference from the API. And so those motion capture events and user requested events, so when a user requests a snapshot, those events will still be logged as well. As far as the web server is concerned, Motion will be storing the media in directories that are accessible by the web server for it to serve up that media through the API. And it will also trigger notifications upon motion detection. So Motion will trigger the web server to trigger a notification. And then the web server will also be retransmitting a live feed that is sent through from Motion to the web server. So for our web server, we'll be using Nginx. There's a bundle called OpenResty, which includes some modules that will help us build our API on Nginx. We chose Nginx because it's fairly lightweight, especially compared to Apache, which can be very hard to configure and resource intensive if not configured correctly. So the web server will be serving media captured by Motion. It'll be rebroadcasting that live stream to authenticated devices, since that's not something that is supported by Motion. The web server will have functionality to purge old images and videos that are no longer needed by us, and then the users can also set files that they wish to not be deleted or archived. And then our web server will be hosting our RESTful Services API, which will allow us to register new devices and provide interoperability between the Android app and the Motion built-in API. So our web server will be interacting with our database, Motion, and notification system. It will be logging notification events to the database, so we'll have a log of all notifications that are sent out to devices. It will be interacting with Motion's built-in API to do configuration changes, certain actions such as start, stop, that sort of thing, and then it'll be interacting with our notification service to send the notifications out to devices.
All right, then I'll elaborate on how our notification service works. Basically, at first we had two types of services. We have SMS-based web services that send a text message to a person's phone, and we also have push notification services, which use a first-party service such as Google or Apple that direct a message from them to the person with the phone. But they both work in pretty much the same way, where the person on the phone will send special information in a token, such as their phone number, or special information related to push notifications that the server will store in a database for whenever, well, by the way, it's all authenticated as well, so not anyone can register in the database. But anyway, after they are registered, if there's any motion event triggered, everyone in the database with a device and that token will be able to get a notification of some sort. And so I did a bit more research in the costs and benefits of both systems. And then the main benefit of the Twilio system, SMS messaging, is that it's more likely that someone's going to receive a text message because push notifications require internet access. And the person either has to have their data plan enabled or Wi-Fi access. But that's not always the case. People want to save battery life, and they could be just in a zone where they only have cellular access. However, push notifications are much more interactive. They not only can you embed just a body of text, you can also embed variables, which then can interact with the app itself to pull up data. And basically, Twilio itself has a cost per message sent, so it's just more expensive in the long run. You would have to pay at least a certain amount of money every month compared to push notifications, where the cost is just non-existent. So we decided to choose push notifications as our primary push notification notification service.
So for our database, we're just going to be using SQLite. It's lightweight and portable, much like the Raspberry Pi. We want to keep resource usage as low as possible because Motion will be using quite a bit of CPU time. So SQLite we figured would be optimal. And this is our ERD. As you can see, there's not very much data that's going to be stored in the database. Just kind of adhering to our ideal where we want to keep the Raspberry Pi as stripped down as possible and kind of minimize everything that's on it. We figured not having an overly complex database is ideal in this situation.
All right, now just overview the main components and features of the Android application itself. And as Sam mentioned earlier, they'll need to be able to establish a secure connection with the web server, and then after that, use that unique token with the web server to authenticate with subsequent requests. And then the Android application will need to be able to request various types of data like snapshots, which will be the images or clips from the current feed, or request archived images or videos, or actually request the actual live feed to watch on their phone. And then finally, it needs to have a settings form type fields to interact with, so they can modify the configuration files and also the dead zones for which motion is ignored. And also a way to interact with notifications. So not only register by sending specialized information to the web server, but also react to push notifications, such that if you get a push notification, you would be able to immediately, once you hit it, see the actual image of the motion detected, and also toggle notifications in case you do not want to receive them for any reason. And so I guess we'll go over basically our main, we have sprints later that will be more specific, but basically I'll be in charge of the notification service and Android application.
I'll be working on most of the back-end stuff on the Raspberry Pi, so Motion, Web Services, API, and then our database.
And then I will be working with Alex and Jake on the Android application components, as well as helping with Motion.
As Chris mentioned, I'll be working on the Android application development.
Alright, so we've chosen to use the SCRUM development methodology. Our sprints will be about 2 weeks in length, starting on the Monday of the week and ending on the Sunday 2 weeks after that. And so we're planning on having 3 meetings per sprint every Wednesday so that we get 2 development and or communication meetings in, and then a final end of sprint meeting on Sundays where each sprint ends. And our backlog will be carrying over between each sprint. And with our current, we have 6 sprints, so the first sprint is projected to end on the 8th of February. And here we're just going to set up some of our basic back-end infrastructure like the web server, the database, and Motion, and then we're going to start developing the GUI and interface for the Android application. Sprint 2 is going to be finishing the GUIs and interfaces, and then we will start working on the web server's security side and the registration, authentication, and file record purging functions. Sprint 3, we'll start developing our web server request APIs for snapshots and the like. So initially we'll just be doing the configuration editing and detection commands through Motion's HTTP API. And then database transactions will be able to get our file list and then get a specific file from that list and then flag other files for archiving. And so our Android application development will be putting together these functions. And so Sprint 4 is finishing up the web server request APIs. We're going to be doing the rest of the HTTP API for Motion, which includes action commands. So these are the commands that we'll be using to, in this case, grab a snapshot, grab video, that sort of thing. And then the Android application will be, again, getting those functionalities working on the Android side of things. So Sprint 5 is going to be used to implement all the live streaming functions. So we're going to set up a secure socket on the web server through which the stream will be, the data from the stream will be sent, and then the Android application will have the functionality required to be able to receive all that data and display it to the user. And then finally, Sprint 6 will be setting up the push notifications, signing up for the Google messaging services, and then getting the Android application to the point where it can handle all the notifications. And as well, we're going to finally add in the door sensor at that point so that we don't get notifications for when we leave the house. So version control, we've chosen to use Git. Our GitHub repository is linked on the slide. And we are committed to releasing our code on Git through GPL license, as the Motion package is also GPL. And that is it.